Hey guys, welcome back. Today I want to take a quick look at some questions that I get asked a lot, and something that I think there's a lot of confusion around, and that is casting. So this is not a main tutorial series video. I am working on one. It will be on skill trees. It's taken a long time. I've got over 20 hours into it, and it's probably going to take 5 or 10 more. So hopefully have that up this weekend. But right now I just want to take a look at casting and discuss that a little bit. So casting is something that there's a lot of confusion around. And we're going to take a look at an example here. In our update player HUD, this is in the player controller, third-person player controller, and we want to get these attributes from our third-person character with abilities. And so we use this get controlled pawn. And what this does is says, hey, the player controller, who's it currently possessing, get me the pawn. And you can see here that it says return value pawn object reference. The problem here is that if I drag off of pawn object reference, I don't get this ability system. It's not there. And so what I have to do is I have to cast it to something else to be able to get the ability system. In this case, I could have casted it to third-person character with abilities, and I would have been able to drag off the ability system. However, I usually make it a point to only cast something as high as I need it to pull off whatever data I need out of it. And so in this case, the ability system is actually first appears at the OWS character with abilities, and therefore I don't have to cast it all the way to a third-person character with abilities, which I know that this pawn is because that's all we possess. And so the question here is, what is happening here? A lot of people ask me, what's happening? I see a lot of people confused about, well, what can I cast to? Why can't I cast from a pawn to a player controller? Well, why can't I cast from a pawn to a game mode? I don't understand. Why when I drag off this pawn here, can I only cast to certain things? And why sometimes when I cast, why does it cast failed? Why does it not work? And then another question I get asked a lot is, isn't casting really expensive? And so those are some questions we're going to take a look at. Before we can do that, though, we have to take a look. I said we wouldn't do any C++, and we're not going to do any C++. We have to talk about a little C++, or we're not going to be able to understand this. And so, quick version. In C++, with object-oriented programming, we have this construct called a class. We have classes. And classes are just structures made up of properties and methods. That's really all it is at a high level. There's properties, which are data, and there's methods, which are code that works on those data. And the connection that you want to make is that blueprints are classes, right? And in fact, all of your blueprints are sitting on top of a class. So for example here, you can see that this says parent class. Notice they use the word class as a blueprint, third-person player controller, and it says parent class OWS player controller. And then you see it says, oh, click to open source file in Visual Studio. So this is not another BP. This is a C++ class, right? So classes and BPs are the same thing, and all of your BPs inherit from classes. And classes have properties and methods. The same way as you see it here, they call it functions and variables. In object-oriented programming in C++, we call it properties and methods, the same thing. So your classes have functions, your classes have variables, right? And the same thing happens in the C++ classes. And one of the things that we can do with this that's really important and a key feature is that we can inherit. And so I want to take a look here at an inheritance hierarchy for third-person character with abilities, right? Because that's actually what's returned here. This returns a pawn object reference, and the blueprint thinks it's a pawn object reference, but I know that that's actually a third-person character with abilities. And so we've got this inheritance hierarchy of third-person character with abilities, which inherits from OWS character with abilities. So this one's a blueprint starting here at C++. So all of these are C++. So we have OWS character with abilities that inherits from OWS character, that inherits from OWS base character, and that's the start of the stuff in the plugin right there. And then they inherit from character, then pawn, then actor, and these are built into the engine. And so what happens when you inherit is it gets to take all of the functionality that existed in the base class or base BP or base object, and it gets to be used in the inherited one. So meaning pawn has everything that actor has. Character has everything that pawn and actor has. OWS base character has everything that all of the ones above it have, right? They keep adding to it. You can keep adding additional functionality. You saw we did that with blueprints we made a base character that we then shared functionality between the mob and the player character. And so this is a key concept for this, and I've got that here in Y inheritance. Shared functionality, right? Shared functionality is one of the main reasons to do that, because now you don't have to duplicate. If there's stuff that's in pawn that you want in some of the other ones, you don't have to duplicate it. It's in one place. A lot easier to maintain. And so shared functionality is one of the keys. The other thing that is a reason to do this is collections. So if I have a third-person character with abilities and I have an OWS character or an OWS character with abilities, I can't put them both in an array, in a list, in a tree, in a map together as is, right? So I can't say, hey, I want to create an array that holds this third-person character with ability, and I want it to also hold a OWS character, and I'd like to throw a pawn in there too, and I want them all in that array or in that list. Can't do that. As is. And so this is where we come in with this idea of having a reference or pointer to something at a lower level. Because what we can do is we could say, hey, I want a collection of actors. And as long as we say that we want an array of actors, we're good. Some of those actors may be just actors. They may be pawns. They may be OWS character. They may be third-person character with abilities. But as long as we have references to actors, we can store them together. Why is this important? Well, because games are made up of loops where we need to loop through things and do functionality with those things that may not all be the same kind. For example, the render loop. It's looping through the actors every frame going, what do I need to render? But they're not all just base class actors. There's some pawns, there's some characters, there's a lot of other kind of actors, a static mesh actor maybe. And so the engine is able to keep an array or list of these references to the actor, and then they can render all of them, all in one nice big loop. And so the collections are a great reason to do this. However, if we have this list of actors and we are looping through them, all we've got is a reference to the actor. And so what we may need to do is when we have that reference to the actor, we may need to cast it to get functionality that is in one of these derived classes. And so that's kind of what we're doing here. So what happens here is that get-controlled pawn is able to act on my third-person character with abilities, even though Epic never knew I was going to make a third-person character with abilities. And they're able to do that because they do it at the pawn level. So therefore, they return me a pawn object reference. They don't know that it's a third-person character with abilities. They just know it's a pawn. But I know it's a third-person character with abilities. And so all this cast is doing is saying, you think it's a pawn, but I know it's an OWS character with abilities, right? And if I'm wrong, if it really isn't an OWS character with abilities, then it's going to fail. Now, you can only cast up and down the hierarchy here, right? So I've got actor, pawn, character, right? These, but let's say I have game mode, right? Well, game mode isn't an actor, so I can't cast to a game mode, right? You can only cast, or maybe I want to cast to an anim BP. I can't do that. I can only cast up and down the hierarchy because here's what I'm going to show you. I like things visual, so I made up a visual thing here of what's actually happening. So this is an oversimplification, but let's say that this actor right here, all that's in it is an integer, an int32, okay? So this is what it looks like in memory, okay? 8 bits, 8 bits, 8 bits, and 8 bits. So 4 bytes, right? And it's called an actor. And we can have an actor pointer or an actor reference that points to this memory location, the first one. And so the type is actor, and so the type knows, hey, I have one int32. That's all that's there. And when I inherit from actor, my actor, and add another int32, it retains the int32 from actor, but also adds my additional int32, and now it's 8 bytes wide, right? And I can have a my actor pointer, or my actor reference, that points to this first one. And if it's a my actor pointer or reference, I get access to all 8 bytes. However, I can also have an actor pointer or reference to the my actor, right? Because my actor inherits from it. However, it only knows about the first 4 bytes. Nothing changed in the memory. The other 4 bytes are still there. I'm pointing at the first, at the first one here. I have my actor pointer pointing at the first byte here in my actor, and it only has access to the first 4 bytes. It doesn't even know that the other exists, but I know, right? I know that it's actually a my actor. And so what happens is that I cast, and I basically say, hey, computer, you thought that it was an actor that only had one int32 and 4 bytes. But now I'm telling you, you can change that type from actor to my actor, and you can get access to the full 8. That's all that's happening. Nothing's changing in memory. When you do this cast, it's not sitting there going, okay, start moving some memory around. We got to start changing some memory. You don't have to do that because it was there the whole time, right? That extra data was always there. And we're just telling it, hey, what you thought was just an actor, the base class, actually has some additional information, which is this int32 that's a my actor, right? It's very simple. The cast doesn't do anything. It doesn't change anything. All it's doing is saying, hey, I know that this is a derived class, and so I'm telling you that that's what it is, and I want to get access to it. And if you're wrong, of course, it's going to call the cast failed. But that's all that's happening at a memory level. Now, a lot of people ask, is casting expensive? What we've just looked at should let you know casting is not expensive. And in fact, I found someone here in the forums who did a test. And so what they were trying to do here was test the speed of casting versus interfaces, right? A lot of people get these confused. We'll talk about this in a minute. And so they basically ran a test, 10,000 casts, and you'll see here that 10,000 casts, that's a lot, was between 79 and 85 milliseconds. Let's say 83. 82. Yeah, let's say 82. Midpoint. So 82 milliseconds to do 10,000. You could do the math on that one and find out it doesn't matter. The cast basically costs nothing. You're not going to be doing 10,000 of them. And that's per frame, milliseconds per frame. And then here they did, on the interface call, they did the same thing. And it was a little slower. It looks like it was averaging maybe 85. So a couple milliseconds slower. And the cool thing about this one is that one of the engine programmers, James G., he weighed in on this. And here's what he says. Fantastic to get some hard numbers on that. This is what I would expect. So what he's saying here is if you had asked James G. Which is faster, casting or interface, he would have told you casting, which is what I would have told you as well. But he goes on to expand on this. The decision to cast versus use an interface is not really about performance. Remember, it was pretty close. In 10,000 ones, it was 2 milliseconds different, but about architecture. And this is the important point here because a lot of people get this mixed up. I would only use an interface when you need one. When you have multiple unrelated classes that should share some behavior or event. So here's what he's telling you. Don't use interfaces for casting up and down the tree, right? That's bad. That's poor form. Don't do that. I see a lot of people do that. People seem to think it's faster. Just because something looks cleaner in Blueprint does not mean it's faster. It's actually more expensive. There's a lot more overhead. And so what he's telling you is you only want to do it with multiple unrelated classes that share some behavior or event. Interfaces were not made to do casting. Interfaces were made to do what he's going to show you in the next example. The example I always give is if you want a flamethrower that can burn things, you probably want a burnable interface that lots of different BPs can implement. If you only care about one thing, see if it is the player that I hit. If so, give them a key. Then casting is a bit simpler because you don't have the hassle of making an interface. So he's saying, even in some cases maybe where, there's some kind of interaction, maybe you don't have to create an interface for every single one. But that's what he's saying. And so what he's kind of talking about here is this idea of an interface. An interface is another thing that does nothing, right? Interfaces don't do anything. Absolutely nothing. An interface is just a contract or a promise, but in and of itself it does nothing. Here's an example of an interface. So I took his example, burnable, right? So we want to have a method called take burn damage. And we want to send in some things like instant damage amount, maybe burn over time amount, burn for how many seconds, and let's get a pointer to the instigator, right? And then let's say that I assign this interface to my actor. Does it do anything? No, absolutely nothing, right? All it is a promise. I'm telling the compiler, I promise that my actor will implement all of the methods in burn interface, which in this case is take burn damage. But adding the interface doesn't do anything. It's just a promise telling it, hey, I'll implement it. Don't worry. And in fact, I think it'll throw a compiler error if you don't keep your promise. If you say, hey, I'm implementing a burnable interface in my actor, and then you don't override take burn damage and implement it like you said you would, then it's going to throw a compiler error. However, there is no functionality in the interface, right? The interface is just saying, hey, I promised to implement this, and here's what I promised to implement. But in and of itself, it doesn't do anything. But the important thing here is don't use interfaces to replace casting. It's slower, there's more overhead, and it's really poor architecture. Now, what you can do in some cases is that what you could do in some of these cases to make it cleaner, if you don't want to have to do a cast every time, not that this is expensive or worrisome in any way, but you could potentially say, hey, I know that the controlled pawn only changes when I possess or unpossess, so therefore you could hook the possess and unpossess events, and you could basically create a variable, probably go all the way and make it third person character with abilities, and you could cache a reference. Nothing wrong with that. We do that in some places. If it's clean, if you know it only changes in certain places. If you have to worry about it changing too often, though, then I wouldn't recommend caching it. But anyway, that is how casting works. That's what it does. It's very, very simple. You're just telling the system, I know more than you do. You thought you had this. I know you have this. And let me have access to it. But it doesn't actually change anything. Memory is the same before and after. And as we saw in that example, it's not expensive, and interfaces are not the way to handle casting. Interfaces are for promising to implement certain events. And then also it's really nice too because there's some built-in stuff in blueprints where you can say, hey, get me a list of everything that implements this, right? So it could potentially make it easy for you. Say you had to, apply burn damage to different objects. Maybe you've got destructible objects and players and other different kinds of things. Remember what James G said, unrelated objects. Interfaces are about unrelated objects. So, okay, well that's all I wanted to talk about today. I hope that helps clear up some confusion there, and hopefully I will see you again soon as we create skill trees. And one of the reasons that this is taking a little bit longer on the skill trees is I'm actually implementing it twice. And the reason I'm implementing it twice is I want to show you two different approaches. And so there's a static approach to coding things, which is usually what you see people do when they're not professional programmers. But as professional programmers, we try not to statically solve problems. We try to dynamically solve problems, which means that we don't solve a specific problem. We solve a family of problems, and then we basically send data at that functionality in a way to control what specific solution that it's solving. And so we're going to take a look at static versus dynamic systems in our skill tree system, hopefully coming up within the next day or two. Okay, until next time, see ya.